Improving manufacturing quality through AI-based visual inspection. I'm Tonya Hall, and joining me is Dr. Heather Ames Versace, co-founder and chief operating officer at Neurala. Welcome, Heather.
Hi, thank you for having me.
Of course. What does Neurala do, and what prompted you to start the company?
Sure. Neurala is a software company that builds artificial intelligence um, software and applications for the manufacturing industry with a focus on visual quality inspection. We got the idea to start the company when we were still in graduate school at Boston University, where we were building neural networks and AI algorithms, and we wanted to try to apply those to real world problems.
What challenges have manufacturers faced to this point when performing visual inspections?
Yeah, so there's usually two solutions that are happening right now in the manufacturing space. And this is specifically for quality inspection of products as they go through the line. So one of the solutions is to use humans to pull off, let's say, every 100 components or products off the line and check them for quality and then make adjustments as needed. Which is a random process, and it could be 1 in 1,000 as well, which results in oftentimes very subjective um, measurements that change from shift to shift of workers, as well as missing stuff in between the process, depending on where you have the people in the line. The second option that a lot of people have is using computer vision. And computer vision is really great for taking measurements, really fine measurements. You know, is a printed circuit board off by a millimeter, and so forth, stuff like that. But what it fails at is those subjective measurements that I just talked about that humans provide. So in let's talk about like in a baking of bread situation, a mass production of bread, uh, it's very hard to build a computer vision solution that would be able to detect if the bread was, overcooked or didn't fill the mold correctly, or its coloring is off. Maybe an ingredient is old, or there's a problem there. And so that's really where artificial intelligence adds the value to the process.
So let's talk about that. How can artificial intelligence address these kinds of challenges?
So the great thing about, excuse me, AI is that it learns by example. So when you feed the system information in the form of data, it allows you to build a system that can make those subjective judgments that are necessary for your problem. And the really great thing specifically about our technology is that you can train it on, let's say 30 images of good product or good components, and it is able to detect components or product that are anomalous or defective rather than having to train it on every possible option. So we've had many customers that have approached us saying, hey, look, we need to find a defect in our product. We took all these pieces and we put holes here, burnt corners here. They made these defects, but they aren't natural. They aren't what you would really see, because defective product it doesn't come along very frequently in the lines. And that's just terrible data to use to build a system because it's not natural. So it's really important in this space to be able to train just on what do you want this to be, and let me know when it's not that, so we can look into it and see if where the problem's at, what the problem is, and really dig into the qualitative assessment of it.
What does it take to build the data set for a AI-based inspection operation?
It really takes not much time at all. So we've just launched Neurala Via, and it takes a handful, 30 to 50 images of good quality product on a line to be able to learn enough information to get started. More information can be added in real time. You don't have to take it off the line to retrain anything. So it's a very flexible solution that you can get up and running fairly quickly.
Versions of this technology have also been applied to use cases for NASA and even drone manufacturers. Talk about that.
Sure. So we actually worked with NASA. It was about 7 years ago. And we worked with them on some pilot projects related to the Mars rover. That's where we really learned and developed this technology called lifelong deep learning, or LDNN. And the reason we needed it there was because in the Mars rover environment, you want the rover to be able to make decisions on its own on Mars, because there's such a lag between what happens in the control center and the rover on Mars. So they were looking for those types of solutions that are flexible and also fairly agnostic to hardware, because there's significant requirements on the hardware that they're able to send into space. So that was where LDNN got its start with us. And then we've just continued it from there. We've also worked with drone manufacturers as well. They are very interested in flying drones around infrastructure, cell phone towers, lines, and so forth, because they want to, again, they want to find defects or problems that aren't able to be seen from the ground, and maybe could be quite challenging to send human operators up into those spaces. Wind turbines is another example, whereas instead they can fly drones around it. And so the drone operators are very interested in being able to learn about what those defects are without having to teach them about it again. And more specifically, to let the operator know, hey, I see something that doesn't look right. So let's go in for a closer look at this place.
Where is the convergence of machine vision and AI headed next? And what kind of challenges will we have to overcome to get there?
Yeah, I mean, there's it's a really, really awesome space to be in. I love this space every day. It's so new and interesting, and there's so many new applications. We specifically are really focused in manufacturing right now, which is super exciting, because particularly in the post-COVID world that we find ourselves in, we have lots of concerns over safety and how to keep workers safe, how to enable people to work remotely as well. And one of the great ways we can do that is with AI. It's another tool in the toolbox to enable those workers to do their job in a safe and effective way. So this is where I see a lot of disruption that's ready. It's an environment that's ripe for it. We've seen a lot of robotics work within manufacturing because it has a lot of repetition, which makes it really great for robotics. But it's also really great for AI for those exact same reasons. There's a lot of control you can put into the environments, so things are quite deterministic for the systems. So that's the place that I'm really excited about seeing AI have a huge impact. And I would say also, in conjunction with that, one of the reasons we haven't seen it so much in manufacturing today is because there's a lot of legacy hardware in this industry. So there's a lot of machines that have been on those lines for 50 years or so. And so it's very challenging to integrate into such old systems, or to motivate purchases of a lot of capital equipment to implement these solutions. So one thing that we really focus on is being a software only solution that can fit into legacy systems. And that's a real added value, brings the cost down, and it allows for a lot more scalability within the manufacturing floor.
Dr. Heather Ames Versace, co founder and chief operating officer at Neurala. If somebody wants to connect with you, Heather, how can they do that?
Probably the best way is our website, www.neurala.com. We're also on LinkedIn and Twitter.
Thanks again, Heather.
Thank you.
Of course, and find more of my interviews right here or at tonyahall.net. Thanks for watching.